day, sneaker viewers. Welcome to today's lecture. Today we'll be looking at special limits. Special limit. We have been solving problems of limits in the previous videos, but in today's video we want to start looking at those that have special rules, and we call the rules special limits. Okay, these are actually assumptions that are made so that certain problems or limits can have a solution. So the first special limit we are going to be looking at is limit as x tends to infinity, 1 over x is 0. Okay, what this limit actually explains is that if you are dealing with a problem such as limit as x tends to infinity and you have something like 2x squared plus 3x all over x cubed plus 4x, all you need to do is to make each of the term a constant over the variable x. Okay, that means eliminate x from each of the numerator of every term. Do you understand? The limit means that if I arrive at something like this, provided that limit of x is to infinity, and I see something like 2 over x, it will give me 0. If it is 2 over x squared, it will give me 0. As long as it's a constant at the numerator and a polynomial at the denominator is equal to 0. That is what this rule is saying. So if I apply it to this question, what I just need to achieve here is just to attempt to make all the term here a constant over x, or just a constant. And to achieve that, what you need to do is to multiply every term by the polynomial with the highest power, x with the highest power. So the highest power here is x cubed, x with power 3 is the variable with the highest power. So which means I'm going to divide 2x squared with x cubed, 3x by x cubed by x cubed, and 4x by x cubed. If I do that, I'll be able to reduce it to where the limit will be applied. So let's see that. So this will become limit as x tends to infinity, 2x squared over x cubed plus 3x over x cubed for the numerator, all over x cubed over x cubed plus 4x over x cubed. X squared will reduce x cubed to just x raised to 1. X will reduce x cubed to x squared. X cubed cancel x cubed, we have 1 left. X into x cubed, we have x squared. So if we look at what we have left now is limit as x tends to infinity, we have 2 over x, okay, plus 3 over x squared, all over 1 plus 4 over x squared. So at this point, it will be reduced so that we can apply the limits that was explained above. And all we just need to do is to record the limits and then change all the parameters that still have x at the denominator to 0. So that will become, so that will lead us to, excuse me, so we call limit as x tends to infinity, 1 over x is 0. So now if I substitute, this will be 0 plus 0 over 1 plus 0. 0 plus 0 over 1 plus 0. So that's just what it means. So in this case, I have 0 over 1, which is 0 as my answer. Okay, so this is another example. Limit as x tends to infinity. So if you observe, what's the highest power here now? X raised to power 4. We have it both at the numerator and at the denominator. So what we need to do, divide through by the highest power. So if I divide each term by the highest power, I'm going to have limit at x tends to infinity, x raised to power 4 divided by x raised to power 4 plus 3x cubed over x raised to power 4 plus 2x over x raised to power 4 minus 5 over x raised to power 4 all over 3x power 4 over x raised to power 4 plus 3x squared over x raised to power 4 plus 4 over x raised to power 4. So let's reduce. X raised to power 4 is gone, we have 1. X to power 4 is gone, we have 3. X cube here, we have just x. X into x raised to power 4, we have cube. Nothing can divide here. X squared into x to power 4, we have square left. So at the end of the day, we are left with limit as x tends to infinity. We have 1 plus 3 over x plus 2 over x cubed minus 5 over x raised to power 4 all over 3 plus 3 over x squared plus 4 over x raised to power 4. So we recall limit as x tends to infinity 1 over x is 0. So we try to remind whoever the person that is going to go through the work is that this is why I'm changing all this parameter to 0. So now this will become 1 plus 0 minus 0 all over 3 plus 0 plus 0. So all this will become 1 over 3. So that's our answer for this question. So let's take another example. Okay, let's look at this example. If you observe the question, the x power is x squared. So I can go ahead and divide every term by x squared. So if I do that, I'm going to have limit as x tends to infinity, x squared over x plus 4x over x plus 3 over x. So we are dividing by x squared, the highest power, all over x squared plus 3 over x squared. So the procedure remains the same. X squared is gone 1, x into x squared just x into x squared just x. So what I have left is limit as x tends to infinity 1 plus 4 over x plus 3 over x squared over 1 over x plus 3 over x squared. Okay, so now if we recall, we're going to say limit as x tends to infinity 1 over x is 0. So if 1 over x is 0, it means I can go back to the question where I stopped here. And I still see x, I put 0. This will be 1 plus 0 all over 0 plus 0. So I have 1 over 0. As usual, this is a case we don't want to see. So since we are seeing it, we have done our best possible to simplify the expression. We are still having 1 over 0, which is undefined. It means the limit doesn't exist. So limit doesn't exist. So this particular limit does not exist since it doesn't have a value. Okay, it's undefined. We talked about it earlier in this course. When the denominator is 0 for a limit problem, it is undefined. So let's take another example. This is another limit problem. If you observe, you really cannot tell the highest power because of this factor on top. Okay, before we can decide the highest power, we have to open that bracket. Altogether, it's only in some scenario or out of experience you'll be able to know what the highest power is, and you still cannot solve it except you expand the numerator. So let's start by expanding the numerator. I will start by expanding the first two brackets. So this will be equal to limit as x tends to infinity. X times x will give me x squared. X times 4 will give me 4x. 1 times x will give me x. 1 times 4 will give me 4. Then my x is still outside. All over x raised to power 4 plus 3. Going further, I have limit as x tends to infinity. These are like 10. 4x plus x will give us 5x. So I have x squared plus 5x plus 4 times x all over x raised to power 4 plus 3. Now I can use the x outside to open up the bracket completely. So I have limit as x tends to infinity. X squared times x is x cubed. 5 times x is 5x squared. And 4 times x is 4x all over x raised to power 4 plus 3. Now it's obvious what the highest power is. The highest power is x raised to power 4. So I'm going to use x raised to power 4 to divide all the terms. And in so doing, we are having limit as x tends to infinity, x cubed over x raised to power 4 plus 5x squared over x raised to power 4 plus 4x over x raised to power 4. Then at the denominator, we'll be having x raised to power 4 over x raised to power 4 plus 3 over x raised to power 4. So let's check what is going. This will go out of this, remain 1. 2 will go out of 4, remain 2. 1 will go out of 4, remain 3. 4 out of 4, gone, remaining 1. So if we write what is left, limit as x tends to infinity, we have at the numerator 1 over x plus 5 over x squared plus 4 over x cubed all over 1 plus 3 over x raised to power 4. So now recall that limit as x tends to infinity 1 over x is 0. Our problem is solved. We now have 0 plus 0 plus 0 for all the terms still containing x at the numerator all over 1 plus 0 term containing x at the denominator. So at the end of the day we have 0 over 1 which is 0. So that's the solution to the problem. So this is another problem on limit as x tends to infinity. If you want to look at for the highest power, observing it like this, you say the highest power is x raised to power 6. But no, because of the factor we have here, it will be good to expand first and simplify. So let's expand. Limit as x tends to infinity. To expand means x cubed plus 4 times x cubed plus 4 minus x raised to power 6 all over x cubed. So if I expand, I have limit as x tends to infinity. X cubed times x cubed is x raised to power 6. X cubed times 4 is 4x cubed. 4 times x cubed is 4x cubed. 4 times 4 is 16. So minus x raised to power 6 all over x cubed. Do you notice that the x raised to power 6 are going to cancel now? Yes. X raised to power 6 minus x raised to power 6 is gone. So if I look at the like term, 4x cubed plus 4x cubed will give me 8x cubed. So now I have limit as x tends to infinity, 8x cubed plus 16 over x cubed. Now we know the highest power is x cubed. So if I divide by that, I'm going to have limit as x tends to infinity, 8x cubed over x cubed plus 16 over x cubed over x cubed over x cubed. X cubed goes out, x cubed goes out, remain 1. So what is left is limit as x So what is left is limit as x tends to infinity, 8 plus 16 over x cubed all over 1. So you can recall now. Recall the limit as x tends to infinity, 1 over x is 0. So since 1 over x is 0 now, I can just go and change this guy to 0. So I have 8 plus 0. You can still put the over 1, which we can also ignore. So 8 plus 0 is 8, divided by 1, 8. So answer is 8. See? So these are different problems on limit as x tends to infinity. If you have still have any challenge after going through all the example we have done, please leave a comment below. If you think what I've done is good enough, at least let there be some positive comment on the comment section, and I'll see you in the next lecture.